Okay, so this will be our last 1 hour, and I think we have quite a lot I want to cover, which is to do particle systems and adding a reflection of like the water. So I hope that, we can try to do that maybe like quickly. I might skip some part that's in the example file, but you can, always ask me over the email or, let me know if you want to know this specific part. So let's add particles. And for that, we just want to emit from wherever this metabole position is. And that will be actually very easy because we have everything set up. So make a sphere, SOP. And sorry, I lost chat box. Okay. And follow the sphere with, well, actually, so copy and paste this transform, since that's perfect. And plug your sphere now into a transform. And we don't need to display that anymore. Now, follow that with particle swap. Okay, and right after this sphere, actually, right after the transform, let's put sort and then random. So now it's emitting in random manner. Let's go ahead and make this to an instance as well. So put into a now. It's gonna be very same thing. We can even copy and paste this leaf to that. Now, because the color is the same, but we just change the position with the particles. But for this one, we don't really, do we actually have, we don't have normals, but no up vector. Oh, I didn't think about using that. So maybe let's see what happens with the normal, but delete up vector, delete the color. And instance tab. So we switch this default instance up with null 4. And then it's upset because it doesn't have a rotation yet. So delete that. Aha, so it is emitting, that's right. And for this material, so go ahead and copy and paste the material as well. And these particles, I just want them to stay orange. So we go back to this Momiji color that's orange. All right. So it's kind of upset because it's saying this normal thing. We just delete that. We're not going to use this. All right. So unfortunately, now that I deleted it, it's just kind of facing straight. I will fix that in a minute. So these particles, I think they should go down with gravity. So go to this particle page and then forces, external force, like negative 1.5 or something. So that it's, it falls. It's 4, right? And that's quite a lot of particles. I think we can reduce this amount of the bars to maybe to 20. And you see some of them stuck there. If you turn on remove unused points, it will be gone. Make sure, just in case reset it. Okay, and then they die pretty quickly, but I want them to live longer. So life expectancy to be 30 seconds. Okay, so they should, now really fall. Okay, so that's what I want. And maybe give a little bit of wind on like x-axis. So it's now going, this way, which is good. Yeah, I think we need to, let's put this here. We should add a rotation to the particle because they are flat. So to do that, well, first of all, sorry, I want these particles to just stick at this 0, 0, 0, which is going to be the water plane. Right now, it just kind of goes forever, right? So go to the particles limit page and limit plane, this y, make it 0. And then hit behavior will be stick on contact. So now they stick onto the ground. That's perfect. Okay, so now we can add some rotation to it. So let's see, where do I want to do that? Okay. Yeah, okay. So let's make some space between the particles and the null one. And then from this particle, again, we'll do SOP to chop to get this TX, TY, TZ position. And then very similar technique, but now this time we're just doing this chop. So put the noise chop and go to channel and then do RX, RY, RZ. And again, put this into an L. And this one, now we bring back to, this time we try like chop to SOP. Okay. And then make sure you connect this one here and then connect this one there. And then in this chop to, instead of this TX to TZ, delete that. We say RX, RY, RZ. We can copy and paste this one. Right? So now this added the new point attributes. These are RX, RY, RZ. And I think this amplitude needs to be like high. We do like, try like 360. Because they are in like degrees. So now this one, we might be confusing. So I'm gonna call it leaf particle because we have a leaf actually on the tree. So these are the particle ones, okay? Go to instance and then now we should have a rotate for Rx, Ry, Rz. All right, so they are rotating. And then it's kind of, it's kind of fun that it's already making this like interesting motion because our card, the center of the card, how do you say, pivot of the card is at the 0 position. If we remember, if we look at this one, you see. So it's not like this, it's rotating from the center, but actually rotating from, this position. So that's kind of makes it this interesting, sort of sort of non-uniform rotation. And I think that's kind of works great. And let's see, should follow you, right? Okay. And this might be just perfect if you are doing sort of like forest floor of some kind. It might look actually better this way. But for this today, I want to make it's like landing on the water surface. So, if it lands on the water surface, it's somewhat like lands flatter, right? So I want to kind of control that utilizing this Ty value because Ty is gonna go to 0. So when it's, when it's closer to 0, the leaf rotation also gets flatter. So select from this SOP2, we select this ty value. And the ty, you know, it just kind of goes from as high as whatever the height of the tree. So it could go like 10 to like, you know, 0, right? So we're gonna limit that using the limit chop. Oh, sorry, limit. Yeah. And then clamp. So minimum can be, well, now I do 0, and the maximum 1 is fine. And then, so we can multiply this value to not all of the axes, because we still want to have randomization in, I think we want to have that in our y-axis. So we will select 2 of the axes from here. So we will select Rx and Rz. And then we will use MassChop. And then plug in your clamped TY. And in the mass, go to combine channels, multiply. I think that's right. That doesn't look right, right? Oh yeah, that shouldn't be right. Yeah, no, that's fine. But it did multiply, so that's what I want. Combine channels, right? Wait, combine chops, I think. Yeah, I'm sorry. Combine chops, not the channels. So now this Ty is multiplied to this Rx and Rz. And we need to still give this original Ry. So we follow this one, middle click and then merge. And then put this one into the merge. And then make sure into the merge node, we do keep last. So we just replace R, Y, and Z like this. Yeah, so it gets flat as it approaches to, you know, 0. And maybe this is too flat. なるほど。なるほど in English. It's, I see. Is it? I love Japanese word なるほど. It's such a good word. Yeah, maybe it's too flat. So in this limit, bring this minimum just a little bit so that, you know, it's not completely. So like 0.05, you know, some are a little like sticking up. And, you know, we can do a lot with this sort of changing the value of the noise. I feel like this transform should be bigger. But then, you know, it gets really crazy at the top, right? So I think exponent. It took a little bit to figure out what feels right. Let me look at my example. I did like roughness. Roughness is like 0.4. Exponent is like that. I guess I didn't change the transform much. Yeah, I kept it 1. Okay. All right. Yeah. Sometimes it takes, you know, a little like playing around these values, but yeah, we call it, you know, that looks fine. All right, so we got the particle working. That's good. 30 minutes, we did it. So I think let's save this here. let's add a water plane. So for that, we simply just use, a grid soap, and follow that with a geometry. And this grid, we want to make it ZX plane. And this should be quite bigger, maybe 50, something like that. And yes, this water reflection technique, I learned it from, I want to show you, the Meta Pana. So he has this tutorial that basically what I'm about to do. So if you want to take time and learn about his technique, please look at this YouTube video. I also posted the link onto the chat. Okay, so how we are gonna do it? We are gonna use PBR material again and assign to my, we can call it water. I rename it to water. And yeah, it's sort of a fake reflection trick that we are going to do. So how we are gonna do it? So we have one camera. Let me put this here. We have one camera. It's outputting. So copy and paste to this camera. So we make second camera and copy this position of the first camera, the translate copy parameter, and in Cam2 paste references, and we flip the Y position. Okay, we can even see it in our viewer here. So now we have two cameras, right? And this one, this bottom one, it also wants to rotate 180 degrees in this Z axis. All right, so it's flipped, right? And this second camera, the reflection camera, shouldn't render this water plane. So if we go to this render 2 and that geometry tab, you can use this caret sign symbol, and if you type in water, that means you render everything except for water. Yeah. And also something I did in the example file. These leaves are kind of very small, but this it has a very angular edges. So it might help if you select both of these render top and then raise your anti-alias. I did like 32 because I wanted to make it really pretty. But depending on your performance, you can lower to like 16. But from default of 4, it should look better if you raise this one. Okay. So yeah, now this render 2 is like rendering from, basically looking from the bottom. And that's basically the trick. Let's sort of like move the camera so that proving that it's working correctly. Let's make now comp. We make 2 now. And then one is a look at. We rename as look at. And then the other one, we call it camera rig. Okay, let's make some space here. So look at, let's put right here. And the rig, make sure the rig, we will parent to each cameras like this. Okay, so this one is connected to each cameras. And then each cameras will look at this look at. So make sure both are looking at the look at, okay? So now if you go to your camera, let's rotate y-axis. You can type in X time seconds. Let's see. That's good. Let's just look at the position a little higher. And you can pull back the camera, a little bit, like that. And what's really cool now that, we are using render pick. So even though the camera is moving, you can still, pick and move your metaball in a correct position you are selecting. All right, so that's pretty good. So this should be our, how the reflection should look like. And go ahead and plug this one into a now. We call it reflection. Okay, and then now go back to our water. So we are gonna make 2 texture sops. So duplicate and then plug that in. And here I do it slightly different from the YouTube, nice tutorial. I'd like to do the first one to be orthographic y-axis. So this will be just a regular UV mapping, to be able to put texture. And the second one is the key for the reflection. And the second one, we will do camera perspective from camera. And then we need to select what camera that is. And I believe it's called Cam2, this one. So you can drag or type in Cam2. And then it's important. So we are assigning 2 different texture coordinates to one geometry. So we leave just texture 1 as is. So the texture 2, this special guy, that's the reflection one, we change the texture layer to 1. Okay. And also, let's go get our reflection image, because it's kind of in a far away. I'm gonna use a select top. Yeah, and then just select this reflection. And we bring it close to our water. Okay, so the way we are gonna use it is we are gonna put in emit map, this one. Okay, and emit needs to be somewhat visible. So we make it 1. I think metallic should be 0, roughness should be 0. Metallic should be 0. Metallic, roughness. Right now it might be confusing if we bring roughness to 0, because it's also reflecting the environment map. So we keep it to roughness 1 for now. Yeah. Sorry, let's make base colors black. Okay. All right. So right now it's just, you can even see it here. It's using the first texture layer, right? It's just mapping as is. The trick, I think it's brilliant, is that I learned is you can click this part for the emit map, and then you can change this one, texture coordinate, to texture 1. All right, so now it's changed to this texture coordinate, and a couple of things we still have to do. We don't want it to repeat, so we change to hold. Okay, and then it almost looks like working, but not quite. It's because it works in the YouTube example because it was the render. The render was square, I believe. But in our case, we are doing 69 render, so we need to match that aspect ratio by going to this texture to transform. so transform has this scale. So we need to, you see, it's passing, right? We need to scale that down by, let's use, since our parent has, you don't have to go, but our parent has a layout that's 1280 by 720. So we can just use that. I mean, it should be same as your render tops resolution, basically. Maybe that's the better way to do it. So let's do that. So copy this resolution, or this one. I mean, they should be the same, but maybe copy this one, 1280 by 720, right? And then paste onto that part. And so we want to do height divided by width. So copy and paste the same thing. And then change first one to H. And then we get the correct aspect ratio, which is 0.5625. Does that look right? So it will only look right if you see a viewer. So this trick, reflection only looks correct from the camera's perspective point of view, obviously. That's kind of what it is, it doesn't look right from here. It only works from this portion here. But yeah, so that makes the reflection, and it's a fake reflection. So it's a little bit of a limitation to it. Let's go ahead and also, it will be nice to have a sky at our environment map render. So we will do that by easily make a sphere. We make a big sphere for the sky. And this one also needs a texture. And this texture, we will use equirectangular inside because we are looking from the inside of the sphere. And then I think sphere, I would like to change to polygon and make the frequency higher. That's maybe too high, like 10. Yeah, that's good. And put it into geometry. Now, this sky, I can just use font map because it doesn't really need to catch light, right? So, and then diffuse can be 0, 0, 0, and specular can be 0, 0, 0. And emit will be 1. Now, environment map will be this one. Ah, wait. It's not environment map, sorry. It's going to be emit map, okay? Here. Now make our sphere, or you can just change the geometry size bigger to the point that it passes camera. I think 50 is good because water plane is also 50, I believe. If I think, oh, so it's a little passing too much. Okay, maybe the water plane needs to be bigger. Yeah, let's make water bigger. 100, all right. And our sphere has a different orientation. Wait, I think, never mind. It's this texture has the different orientation that we can change. So if we change to y-axis, then we get a nice reflective environment as well. Let's see. That looks good. Okay. Okay, so now go back to our water. We're gonna add a little nicer touch to this. So our reflection is, you see it's sort of jagged there. Right here, and quite ugly. And and that comes from not having enough divisions in your grid. Because when you are UV mapping, you always have this. So if we even see in a wireframe, another useful technique in this geometry viewer, you can always turn off something you don't want to see. And for now, I don't know sky is working, so turn off this blue icon for the display. And where is our camera? So camera is here, right? It gets jagged because see how big this square is. So it doesn't know, what to do, when it comes to in between this square as far as the UV mapping goes. So as you increase this grid resolution, which is these rows and columns, I want it to be uniform. So I copy and then paste parameter so that they are always same divisions. So try increasing. I'm on let's look at this one. So yeah, when it's low, it's just not clean, right? So you need to give a decent amount of divisions to look right. So I do like 100 for now. So now it's nice and smooth. Yeah, so that's good. And so now I think this is the interesting part we can also do since it's already PBR. And remember we had this roughness. If we bring that down, it's not in exactly the same spot, but it's nice to maybe have a little also, touch of this reflection that we can use and then make it a little bit bumpy so that it looks like a water surface. So we bring roughness down to closer to 0, but not completely. And then emission, we can bring that down a little bit so that it's not, all the way to 1. Okay, so we kind of have this double reflection, which is suspicious, but it's okay. I think once we add a little noise to it, it's gonna look something. And noise can be just small, 256, and put into normal map, and go to PBR map. We can add a little normal map, and move your noise in the transform. I can just do, in the z-axis at time dot flame. Too fast, so times or divided by 100. Maybe it's too fast. Yeah, something like that. And your noise can be smaller in the period. Yeah, one thing is you don't want to add too much harmonics because that makes it really slow on your computer. So, you try to use harmonic spread if you need that kind of effect. Maybe we can adjust our PBR's roughness value a little bit. Yeah, I mean, it's all sort of fake. So it's not it shouldn't work a physically correct. It should be almost 0 in the real life, but it looks a little too metallic to me. Oh, that's because the metallic is probably 1. Is that why? Maybe. Metallic should be 0, I think. But yeah, just kind of trying to make it look like water. That's the job. And then again, emission is added over this PBR's reflection. So kind of we have this double reflection going on. And yeah, I think at this point we might want to turn off our medable rendering, which is this render flag. Yeah, and starts to look pretty cool, right? And let's see, we have like 10 minutes. One thing I wanted to mention about this reflection technique is it tends to break if your camera is too high up in position. You see it starts to get stretched, right? Yeah, so there's some limitation to it, but it would work if you're only doing reflection for the tree. But for the environment, you can't really go too high because, you know, camera also, camera is like kind of seeing the sky at this point, right? So it kind of gets break in this area. So yeah, I kind of cheated and tried to keep it as close to 0 works. But now if you're too close to it, now that you don't have enough division, so it starts to get really zigzag here. So you kind of have a little like sweet spot, you know, maybe like around like 1.5 to like 3, somewhere around that line. Yeah. So in this example file, I also added like a little mountain. That's something we can do quickly. We add a grid and then geometry and make our grid again ZX plane and make it polygon. And we also need to have some division on this one too. And yeah, we can just make a circular ramp and then make it to hold and hold. And then we need to swap the color, so that will be black and this be white. And just put into the now. I'm gonna be doing a little quickly here, but you can just you know, watch it if it's too fast. But basically, we can just simply make quick displacement map for the little mound that, you know, this tree can sit on. So for that, we go to this map and we need to have, yeah, so what I did was I have some asset for you, which is here, asset, image. Sorry, it's confusing, but it's in geo. In the moss ground, these are textures I found. It's a free texture from Megascans. And Megascans has a lot of really nice textures. And I like to use this moss, you know, material for the mound. So I will grab albedo, AO, roughness normal, and displace. I don't actually need displacement, so I need that 4. Roughness normal. And yeah, this is gonna be super easy. This albedo goes to color, roughness goes to roughness, normal goes to normal, and AO goes to ambient occlusion. So once you assign normal, you get this height map option. And in my case, I use height map with this one. And turn on displace vertices. And then maybe I need to make it. Oh, I don't think I assigned this to my material yet. Here. Ah, there it is. So it's pretty funny. Ramp is linear, so maybe change to ease in or like, I don't know, ease in. It's fine. But basically, this, you know, whiter it is, it gets displaced. So you can, you know, always quickly make a little terrain in this technique. And it's always cool to add a little like noise or something to this one, which I did in the examples. So if you have like a little noise to it, you can multiply that. And my noise is, you know, a little too strong. So I think, yeah, something like that. And this, you know, since we are using the vertex displacement, which, you know, it is, doesn't look like displacing, but it actually, you know, it's a technique, it's actually being displacing vertices in the rendering. So it's fast, but you still do need to give a decent amount of copy and paste the rows and columns, a decent amount of divisions to make it look good, you know? Unless you are doing low poly style, which is always cool too. Yeah, and then, you know, noise right now is 256, but if you are working with like a larger terrain, you might want to go like, you know, more resolution on your noise, obviously. And yeah, it's nice that, you know, it's also working in my reflection. I think it's this one. Wait, something doesn't look right. Okay, I know what's going on. I think, okay, so you can see the rendering, but make sure you change your see, okay, this is good. So you see it's displacing, but also going negative value. And this fake reflection technique doesn't work if your object passes 0 axis, because the camera is seeing that, you know, the bottom part of like what's not supposed to be seen, right? And your displacement has this displaced midpoint. So make sure that's 0. Yeah. And then it's ugly now, but we can use same ramp to, and then also add an alpha channel to it. So right now, since it's a square, but we can make it rounded, you know, so that it has a rounded alpha map, and make sure turn on the blending. Now make it a little tighter, like that. So now, you know, you get a little nicer thing. I will make it a little smaller. Now the tree is like stuck in the mound. Make it shorter. Display scale makes how much it gets displaced. All right. So I know I have 5 minutes or like 4 minutes and not much left. And maybe I wanted to also open up like a question, but maybe from here, I think what's beneficial might be, I did, in the example, I did add also in the geometry, there's also this free rock from Megascans. And this is, you know, very easy to just add by drag drop this FBX like so. And this rock is so big, so 0.01 this import scale. All right. But yeah, basically what I did was I did a, you know, quick instancing of these rocks in an example file. Just like I made like a, let me quickly show you. So this is, we are looking at now example file. Here's the mound. And yeah, this one is the rock. Yeah, so I made it a little like cluster, right? And you can see that happening inside of this network. I just have a sphere and just kind of, you know, blasted just the top portion of it. And simply just using that for instancing these rocks. And I use the same technique, you know, get the txt, ytz, and add a noise to it, I did, I guess, scale as well, you know, randomizing the rotation of the rocks so that they look a little bit more natural. So I'm not gonna do this step by step because time is definitely running out. And yeah, the couple technique, you know, is I used depths. I took a depth top, and what's important for this one, I guess, is that your camera, it uses your camera's, if you go to view, it has this near and far. So it totally depends on, you know, your scene scale. But in my case, you know, I made my far to be like 200 and then near to be like 5. And you can see it changes if I change this value. See, so the closer it is, it's dark, and farther it is, it's white, right? Yeah. So yeah, you kind of need to get the right amount, you know, prepared to be able to use this Luma blur. And why do I have these two Luma blurs is, first one, this white Luma blur is using white value. So it's blurring the, you know, farther part because the tree is in the middle. So I'm first doing blurring the farther part in this Luma blur white. So, you know, you need to also kind of fine tune this value, right? And then after that, I'm doing this now front blur. So that's like a darker part, which I guess, this is how much blur it is. Wait, I'm sorry, I'm still selecting the other one, this one. Yeah, so this one I'm kind of like, how far, you know, you see it's going. Yeah, so that's how you kind of add a little nicer depth of field and just added a little like ramp and to, you know, add a little vignette to the final image here. Yeah, and then that completes the workshop today. If you wanted to export your tree, the problem was there was a little mesh to it. If you follow with convert, so by default, it's gonna convert the polygon. So now, you know, no mesh, okay? So now you can right click, save geometry, and then, you know, choose FBX and I say replace, but I was able to export. I didn't check it, but yeah, at least I was able to export without error message. So yeah, that's it. But yeah, I hope you get to have fun, you know, apply to your own project. And what's really cool, I think, is technique is that, you know, you can imagine you can be building the different tree textures. And, you know, now you can play with randomizing your tree, right? So you can kind of like, oh, I like this shape, I like that shape, and like, you know, change your different trees. And you remember you have like all these parameters even to play with gravity, maybe tree is dying, you know, stuff like that. Yeah, and also, you know, right now we are using this mouse input, but I think, you know, I was inspired at the last workshop. Somebody was wondering how to make it, you know, interactive with like maybe Kinect sensor or something. So that's kind of how I was inspired to make it interactive. It's not going to be one-to-one in this case because I'm using RenderPic. So you need to like figure out how to, you know, take your position from the sensor into RenderPic. But I'm sure that's not too hard. Yeah. Yeah, thank you.